average of 2 points is middle point. Now, what is the average of 3 points? First or second? Second one, right? But what's wrong with first one? So in this video we're gonna try to understand what average and weighting average is with some few example. Now there are three important things before calculating weighting average. First, weight. Second, scale or space. Third, system. System is nothing but set of points or members with respect to their position in space. And roughly speaking, weighting average is nothing but the center of that system. Here, center doesn't necessarily means middle point. Now, if we consider only one point as a system, the center of that system is that point itself. We may call that singleton system. Now, if we consider two different points on scale as a system, then its center is the middle point between them. Now let's check out some examples. Let's see this kind of unrealistic example. Consider one person having a very rare object and he wants to sell that object at a price of 8 gold coins at that very moment. Say he has a clone who wants to buy that object but at a 4 gold coins. Both do the bargaining with all they have got. But since they are both the same, their capability to bargaining is also the same. Thus they both have to agree with a average price of 4 and 8, that is 6 gold coins. But now consider a situation in which we have two buyers who wants to buy that red object at 4 gold coins and seller want to sell that object at 8 gold coin. Now assuming both parties will do the bargaining with all they have got, the final price which both parties will agree is slightly lower than the average of 4 and 8. So you see it's kind of like tug of war where each side wants center to their position. The more the number, the more strength, the closer the center to that position. In this case, by this formula, the final price is 5.33.
Wait a minute! Who are you?
Yeah, but where this formula came from? We'll see that later, but for now, we will see why this is true with using the example of center of mass. First, let's see the definition of center of mass. It is a unique point at which if you apply the force, there will be only a linear acceleration but not the angular acceleration. Or, it is a unique point at which the whole mass is supposed to be concentrated. The more the mass at that particular point, the closer the center of mass at that particular point. And assuming COM is a linear function, we get an inverse relation like this. This can be seen as a primitive form of center of mass. By cross multiplying and adjusting, we get m1 r1 minus m2 r2 equal to 0. But since r1 and r2 are in opposite direction, we get m1 r1 plus m2 r2 equal to 0 in vector form. Now we just prove that summation of mi equal to 0 for 2 mass. Let's see for 3 point mass. Now instead of considering 3 point mass as a system, we first consider 2 point mass as a system and then combine the new system with third one. So the new system has a mass m1 plus m2. So by previous argument we get m1 r1 dash plus m2 r2 dash equal to 0. We will use this fact later. Now the center of mass between the new system and the third one which we desire. So by previous argument we get m1 plus m2 into capital R plus m3 r3 equal to 0. But we want in the form of r1 and r2, not in the form of capital R. So let's draw a vector from m1 and m2 to center of mass and put the value of capital R by the triangle law of vector addition. We get summation of mi equal to 0 for 3 mass. Similarly, we can prove this for n point masses using induction. But this doesn't quite look like the formula we want because we didn't introduce scale or space. So let's introduce it. For the sake of simplicity, we consider any mass mi and the center of mass of that system and hide the other masses and name the vector from origin to mass mi as xi and origin to center of mass as x. As summation of mi ri equal to 0, just put the value of ri by using the triangle of vector addition and solve for x. We get desired formula we want. Now let's come to the question which I asked at the beginning of the video. What's wrong with this formula? But before that, let's see what we want to find. We have three singleton systems with centers namely x1, x2 and x3. So we want to merge them and find its center. We can merge system in two ways. Either merge three systems simultaneously or first merge any two singleton system to make new system and merge that with third one. So the problem with the formula we saw is that it assumes x bar a center of singleton system. But in reality, there are two members agreeing with the center x bar to form a new system. So after combining that new system with third one, we have to use weighting average formula to find the center. So 2 into x bar, as there are two members in that new system, plus 1 into x3 upon 2 plus 1, which is equal to x1 plus x2 plus x3 by 3.
Now let's think about this question. Can we take any quantity as a weight? Before answering this question, let's try to understand what is meant by extensive property. In high school, we learned extensive property as a physical quantity whose value is depend on size or matter of the system, which is indeed true. But what are the characteristics of extensive properties? If we observe the examples of extensive properties, almost all extensive properties are positive, like mass, volume, number of moles, or any conserved quantity. Now, second but important characteristic is that extensive properties are additive for subsystem. That is, if we merge two subsystem, extensive property will be added for new system. This we have seen previously when we merged two point masses or consider them as one system. Then the mass of that new point mass was the addition of original point masses. Similarly, if we merge two containers of volume V1 and V2, then the volume of new container will be V1 plus V2. Now consider the situation where Mr. C have two spheres which looks identical, but when Mr. C tries to lift both, one of them feels heavy compared to other. So even though they look identical, what's the difference between those two spheres? Of course it's mass, but with respect to what? Correct, volume. The sphere which is not heavy may have some space which is not occupied by mass. So the difference between those two spheres is amount of mass with respect to volume, that is m over v, which is known as density. So is density an extensive property? We will see that after this example. Consider two containers with same volume filled with ideal gas or air molecules with some kinetic energy. Say by some means we know that container 1 has more total kinetic energy than container 2. But as in previous example, we'll again ask the question with respect to what? Here also the answer is volume. So the kinetic energy with respect to volume is known as pressure of gas molecules. Note, we ignore constants like 3 by 2 for simplicity. So is density or pressure are extensive properties? That is, are they additive for subsystems? That is, if we merge two containers of same pressure, will the pressure get double? Let's say both containers have same pressure, but kinetic energy and volume are different. After merging, since the kinetic energy and volume are extensive properties, that is, they are additive, so the pressure of the merged system will be this, which is surprisingly equal to the pressure before merging because of this little fact. So the pressure is not additive for subsystems, that is, pressure is not an extensive property. This kind of properties are known as an intensive property. Or we may define an intensive property as the ratio of two extensive properties. Now, We will define an extensive property which is in numerator as F extensive property, where F stands for flow, and an extensive property which is in denominator as C extensive property, where C stands for container because it contains F extensive property. Also, forget about the definition of a system which I told at beginning of the video, which was wrong but useful for introduction. We will now define system as a space of C extensive quantity. Now, let's find some characteristic for intensive property. So, in that container example, if you observe that if we measure pressure at any point in that system or in that container, it will be same because kinetic energy per volume, that is pressure, is like a concentration. In a stable system, if we have a different concentration, it will try to minimize the difference in concentration, or you may see it like to minimize the energy difference, and then it will establish an equilibrium, so pressure will be same in that container. In fact, any extensive property will be uniform in a stable system. Now let's take another example.
Now let's take momentum, which is F extensive property, which is contained by mass, here C extensive property. So in this case, momentum with respect to mass is an velocity, which is an intensive property. So you see, mass can be both F extensive or C extensive property depending on different situation. Now try to prove that ratio of two intensive property is also an intensive property.
Some intensive property are defined like that. As we have seen before, if we merge two containers filled with air of volume V1 and V2 and pressure P1 and P2 respectively, volume will add up, but pressure will not. So, what will be the resultant pressure for new system? Well, let's find out. If we consider container 1 has more pressure, that is kinetic energy with respect to volume, than container 2, and if we merge them, then kinetic energy of container 1 get more space than before. So kinetic energy of container 1 will starting to lose and pressure of container 1 will starting to reduce. At the same time, container 2 gain kinetic energy from container 1 and pressure will starting to rise until both container will have same pressure, say PF. Since there is loss in kinetic energy in container 1 and gain in kinetic energy of container 2, the loss of kinetic energy of container 1 must be same as gain in kinetic energy of container 2. But the loss of kinetic energy in container 1 is initial kinetic energy minus final kinetic energy, and gain in kinetic energy of container 2 is final kinetic energy minus initial kinetic energy. So solve for PF, we get PF equal to weighting average of P1 and P2 with respect to weights V1 and V2. Similarly, if we consider two containers with temperature T1, T2 and number of moles N1 and 2 respectively, then the resultant temperature of merged container will be the weighting average of T1 and T2 with respect to number of moles N1 and N2. Also, you may get the idea why we use RMS value in some cases. Now consider another example in which we have two bodies with masses m1, m2 and velocities v1, v2, but say those two bodies have some strong glue on it so that after collision they will stick to each other. Say body 1 has more velocity than body 2. Now similar argument which we have seen in previous example. In this case, the momentum of first body will lose and the second body will get momentum from first body. Therefore, momentum which have lost by first body should be equal to momentum which have gained by second body. And so we get the resultant velocity of merged body as the weighting average of V1 and V2 with respect to weight M1 and M2. Although extensive property are used for physical quantity, we may use its structure in economic also. Say we have a country with only 5 people and it's a closed economy. That is, there is no import or export take place. Therefore, national income per year equal to national expenditure per year, and both will be equal to national product. National product is nothing but a total value of finished goods and services produced by a country's citizens. Say, name of the currency in this country is 10. Now let's say government of this country only provide one of the person, say A, 410, and he spent that 410 to buy a book from person B. Now person B spent that 410 to buy 2 apple from person C. Now person C spent that 410 to buy 4 similar cookies from person D. And then person D spent that 410 to buy 1 bottle of oil from person A. Now, if we look from seller's point of view, they get income from the number of goods and services they sell. So, the national income with respect to total number of goods and services sold, or national income with respect to total number of transactions in a country per year, is equal to average price of goods and services in that country. In our case, average price of goods and services is 210. So, national income equal to T into P. Now, if you look from buyer's point of view, they spent money on goods and services with the amount of money they have got. So, the national expenditure during a year with respect to total number of money in circulation in an economy during a year is a transaction velocity of money. That is number of hand changed by money during a year. In our case, our 410 is first transferred from person A to B, then B to C, then C to D, then again D to A. So hand change by 410 is 4, that is velocity of money is 4. Therefore, national expenditure equal to M into V. But national expenditure equal to national income. So we get MV equal to TP, which is known as equation of exchange. Now say we have two countries A and B with close economy and with same value of currency. Say country A has average price of goods and services per year P1 and total number of transactions in country A per year is T1, and for country B average price is P2 and number of transactions is T2. Assuming both country have constant supply, say we want to merge both country, then new country have total number of transaction T1 plus T2, but as for the price, say country A have more or higher average price compared to country B, then what will be the average price of new country? After merging of two country, since country B have lower average price, people from country A will be start to buy things from country B part. As supply will not change in country B by assumption, total number of transactions from both country will not change. But since demand at country B part is increasing, price level of goods and services at country B part will start to increase, and price of goods and services at country A part will start to decrease until both country reach same price level. Say final price be PF. Therefore, income of country B part will increase, that is they gain or profit. But at the same time, country A have to bear loss. So since gain of country B part will be equal to loss of country A part, solve for PF, we get PF equal to weighting average of P1 and P2 with weights T1 and T2. This formula doesn't seem to have any real life application. But instead of considering price and number of transactions on space scale, if we consider it on time scale of particular good and service, then it does. Extensive property are examples of measure in measure theory. Measure is a function which measure measurable space. Say A is union of disjoint systems, each have its own intrinsic value. Then new system has intrinsic property this.
Now let's come to the next question. Does negative weight make sense? Now, as we have previously seen, almost all extensive properties are positive in physics, but we can not only extend it to the negative numbers, but also complex numbers in maths. So we are going to see about a negative mass. But before that, let's see an interesting fact. Let's assume we have only two bodies in the universe of mass m1 and m2 separated by some distance. Therefore, there will be no external force on the body except the gravitational force by the other body. Assume there is no initial movement, but due to the gravitational force, they will attract and collide at some point. That point is the center of mass of the initial position of two bodies. Before continuing, try to prove this fact by yourself. So let's see why this is true. Say by the gravitational force, the two bodies will collide at some point. We don't know whether this point is center of mass or not. So by the Newton law of gravitational, the magnitude of force experienced by each body is F equal to G into m1 m2 upon r square. Here our r is r1 plus r2. Due to the gravitational force, body of mass m1 will accelerate to the body of mass m2 with acceleration a1. By Newton's second law of motion, the force experienced by body 1 due to body 2 is m1a. Cancel m1 and we get the value of acceleration a1. Similarly for a2. Now apply the second equation of motion s equal to ut plus half at square on both bodies respectively. Since the initial velocity is 0, distance traveled by both bodies is r1 and r2 respectively, and the time spent by both bodies to reach final position is the same. So we will call that time t. We get r1 equal to half a1t square and r2 equal to half a2t square. Now put the value of acceleration, we get this equation. Now divide r1 by r2, all the stuff cancel out except mass. So we get r1 by r2 equal to m2 by m1, which we have seen before as the primitive form of center of mass of two bodies. Well, that concludes proof. So two bodies indeed collide at the center of mass when there is no external force. But if there is an external force, then it comes to the two body problem.
Now let's come to the question of negative masses. What we know is that positive and positive or negative, that is like masses, should produce attractive force towards each other. But note that the direction of acceleration of negative mass is opposite to the direction of force on negative mass. So any mass will repel by negative mass. We can see that by this formula too. Say m2 is negative mass and m1 is any mass, then direction of acceleration of m1, that is direction of a1, is opposite to the direction towards negative mass. That is, any mass around negative mass will repel by it. So consider a positive mass of magnitude 2m and negative mass of magnitude minus m. Then positive mass will attract negative mass and negative mass will repel positive mass. But attractive force of positive mass should be greater than repulsive force of negative mass due to its difference between masses. So eventually they will collide at some point. We can calculate that point using the previous fact, that is, that point is center of mass of initial position of mass system. So if we place positive mass at origin and negative mass at some distance d, then they will collide at minus d. So what if both masses have same magnitude but different sign? What is the center of mass of that system? So if you calculate center of mass, we get kind of strange answer, that its center of mass is equal to or tends to minus infinity. That is, they collide at minus infinity. Well, let's see if we can make sense of this calculation. Well, positive mass attract negative mass and negative mass repel positive mass. But magnitude of force of attraction and repulsion are same, so they will just move towards left. And some say this breaks the rules about energy, so negative mass may not exist. That's it for today guys. I hope you enjoyed it.